Hi all, welcome back. In this session, we will discuss how to conduct a paired sample t-test using SAS, a powerful statistical tool for comparing the means of two related samples. In this tutorial, we will guide you through the entire process, so let's dive right in. Imagine you are a savvy marketer looking to assess the impact of an email marketing program on sales. To achieve this, you have carefully designed a study involving 30 customers. You have administered a pre-test to all of them and then exposed to your email marketing program for a month, followed by a post-test of similar difficulty. Now you are eager to find out whether this marketing initiative has made a significant difference in sales or not. To answer that question, we will perform a pair sample t-test. This is ideal because each customer has both a pre-sales value and a post-sales value, allowing us to directly compare the changes. But before we proceed with the t-test, we need data. I tried to look the data in SAS help library but did not find out the dataset to conduct a paired sample t-test. And that's why we will create our dataset in SAS with the following code. This code will form the foundation of our analysis as it stores the pre and post sales value for each customer. To get a sneak peek of our data, we will use a proc print procedure to see how our data looks like. Let's run the code. And you can see here these are the top 10 records, and you can see for each and every customer we have the pre-sales value as well as the post-sales value. Now let's define our hypothesis. In a paired sample t-test, we typically set up two hypotheses. Null hypothesis: the mean pre-test and post-test sales values are equal. Whereas alternate hypothesis, the mean pre-test and post-test sales values are not equal. Now it's time to perform the paired sample t-test using SAS. This is where the magic happens. Let's see how we can do that. We are going to call the proc t-test procedure and we will call our dataset sales and alpha equal to 0.05. Here we are going to call paired options and we will call a variable pre star post. Run. That's it. Now let's run a code and see our output. This code tells us to conduct the t-test on a sales dataset with alpha, which is the significance level of 0.05, and it specifies that we are analyzing the paired values in the pre and post columns. Now let's decipher the results we obtained from the t-test. You can see here the mean difference. The title is difference pre minus post, and you can see the mean difference between pre and post test scores is approximately minus 7.3667, and our 95% confidence interval for the mean difference is between minus 12.0516 and minus 2.6818, and I would like to highlight that it does not include 0. Means from this particular methodology you can come to know that our test is significance, but we will come to that. This range provides a sense of how precise our estimate of the mean difference is. The t-test statistics is minus 3.22. It measures how many standard errors the mean difference is away from 0. Moreover, the p-value is 0.0032, and this is crucial. Since it is less than our chosen significance level of 0.05, we can confidently reject the null hypothesis that there is no significant difference between the pre and post sales value. In conclusion, our analysis indicates that the email marketing program has had a significant impact on sales. With a p-value of 0.0032, we have a strong evidence to suggest that the mean test scores are indeed different for customers before and after the program. So there you have it, guys. This powerful statistical test can provide valuable insight into the effectiveness of various interventions, helping you make data-driven decisions with confidence. Thank you for joining us in this tutorial. If you have any more questions or need further assistance, please feel free to reach out. Thank you and have a great day.